Okay, so here we have the same question that you probably already saw in section 4.1. Remember, I told you 4.1, 4.2, and 4.3 are basically different methods to solve systems of linear equation. So I'm just going to show you the same problems that we did in 4.1 using the new method, substitution method. And if you prefer the substitution method, feel free to use that. So we have the two same equations, x plus y equals 4, x minus y equals 2. If you were paying attention, we already know that this has a solution. There is one ordered pair that will make both of these true, just one, and that's 3, 1. But if you didn't know that, and you said, okay, I just did not really want to learn the graphing method, so I skipped over that because you hated graphing. Let's see if you like the substitution method better. Now the substitution method, just like I had with the graphing method, I have all the steps here. So what you're going to do is, if possible, choose an equation that has a variable that has no coefficient, okay? The reason why that makes it easier for you to solve for the specified variable. If all the coefficients have a variable, then you just choose any equation, right? So you want to choose an equation that has no leading coefficient. Once you choose an equation, then you're going to solve for the specified variable that had no coefficient. Okay? So if you had 2x plus y, you're going to choose the y to solve for because you want to ignore the coefficient 2x. We know how to solve for a specified variable. Remember, that was underline a specified variable, move anything that was added or subtracted, and then do any divorcing. Once we solve for the specified variable, then what we want to do is take the second equation that you didn't touch, and you're going to rewrite it by using parentheses for the one variable that you did solve for, that specified variable. The reason why we call this the substitution method is because in step 4, you're going to plug in the expression that you just solved in step 2 into the other equation. That way you would only have one variable, either all x's or all y's, not x and y. Once you do that, then you're just going to solve for that variable that's left. If you're able to solve, then you'll just get 1/2 of the ordered pair. Remember, you have to have an x value and a y value for an ordered pair. So if you get 1/2, then all you're going to do is plug in the other half into any of the original equations, and it'll get you the second half of the ordered pair. But if all variables disappear, then we're going to have to look at our leftovers. If you get a true statement, then that's where we're going to say that your answer is infinite number of solutions. But if you get a false statement, that's where you're going to say that there's no solution. Okay? A little confusing, but we're going to show you 3 problems using this method so that you'll get the hang of it if you like this method. So let's take a look at the board and look at step 1. Step 1 says, hey, if possible, choose an equation that has a variable with no coefficient. Notice this x, no coefficient. Notice this y, no coefficient. Notice this x, no coefficient. Notice this y, no coefficient. This is unique. This is one of the simpler problems. Question 2 and 3 will have coefficients. So notice, since none of them have coefficients, you can choose any equation that you want to solve for. So just choose. Now again, if this had a 5 and this had a 7 and this had a 3 and this was nothing, then you would choose this equation that had no coefficient. But since I can choose either this or this, it doesn't matter. Choose one. Let's say I went for, I don't know, bottom one. Doesn't matter. Choose one of the equations that had no coefficient. So I chose that one. What am I going to do with that? From the chosen equation, solve for the specified variable that has no coefficient. So let me solve for x, because you can see there's no coefficient here. If I use y, I would technically have a -1. So I want to choose x. And how do I solve for the specified variable x? Remember, I want to get x by itself. Remember how there's a left-hand side and a right-hand side? My goal is to get x by itself. So remember, underline the letter that you're asked to solve for, and then move anything that's added or subtracted to the underlying variable by doing the additive inverse. Remember, additive inverse, opposite of a negative, would be to add. And if I add a y to the left, I have to add a y to the right. These cancel out. Some left was x. And remember, a constant and a variable you cannot combine. So you're going to keep them separate. You can put the 2 first, then a plus y, or you can put the y first and then the constant last. For this, it doesn't really matter. Okay? Now that you got x solved by itself, remember, take this second equation that you did not use. Okay? So for us, this was our first equation. This is our second equation. So take the equation not used, the second equation, and what we're going to do is rewrite it. But notice I solved for x here. So what I'm going to do is I'm going to not write x, I'm going to write a set of parentheses. So instead of x, put in a set of parentheses. Plus y equals 4. Okay? So that's what I mean by take the second equation and replace the solved specified variable, that x, use parentheses, empty parentheses. So that's what I did. I solved for x here, so in the second equation, I replaced x with those empty parentheses. We know the next step says plug the expression from step 2. Remember, x equals 2 plus y. Plug in the expression sign into those parentheses. So I'm not plugging this whole equation, just this side. Remember, half of it's called an expression. So I'm plugging this here. Because we said in our original problem, x plus y, well, if I'm saying x is the same thing as 2 plus y, I'm going to substitute x and call it 2 plus y. Now that I plugged in, substituted, step 5 says solve for the variable. Okay? Notice there's only one type of variable left, y's. How do we solve? Well, we got to get rid of these parentheses. Remember, slip in a 1 to distribute. So we get 2 plus 1y plus y equals 4. You know, once we simplify, we know this is the variable side. This is going to be the constant side. Notice that we can collect like terms. Y's with y's. Remember, if they're on the same side, we circle. We don't move, we just circle. So 1y plus understood 1y here is 2y. Then what you want to do is move that 2 over. And then get y by itself. Get rid of the coefficient, divide, and we get y equals 1. Now remember, if the variable was solved, which we did, we get y equals 1, this is only half of the solution. Because remember, a solution to a system is an ordered pair, or no solution, or infinite number solution. So we needed to have an ordered pair. An ordered pair has an x and a y value. So we know 1/2. What half do we know? Y equals 1. How to get the other half? Plug that variable that we just got into any of the original equations, and that will give us the other half. So remember, we know y is 1, so we got to figure out what x is. Use the original, and you can figure it out. If y is 1, then x would have to be 3. 3 plus 1 would give you 4. So you would just plug it in. Or if you wanted to plug in the second one, that's fine. You can plug in by using parentheses just like you were plotting, and then just solve that way. Is the x minus 1 equals 2. Add 1 to both sides because you want variables on one side, constants on the other. And you still get x equals 3. Remember, x, so that goes in the x spot. So what do we like about this method? We don't have to do any graphing. We didn't have to worry about, Were our lines lined up correctly when we were reading the intersection? Did we read it correctly? So at least if your hand is one that's not steady or that you don't have graphing paper or straight edge, this might be a better method. We got the same answer that we did when we were graphing 3, 1.